Welcome everybody. Me Suresh Jha from DOEC Pulcho campus. So here we have four gentlemen regarding the subject EDC. They are here to present their presentation on their project that they have done in the first year. So here they are now they want to present their presentation. We have Honorable Bikal Adhikari sir there to witness the project. So we should welcome him. So, gentlemen, with your introduction, now you can start your presentation.
Good
And be
morning.
loud.
Good morning, everyone. My name is Tiposan Khorga from 079 Electrical Batch, and today I am here to present our presentation regarding automated toll collection system. First of all, I would like to introduce our group members.
So it's Deepak Kumar
And myself, Tiposan Khorga. So our project is Arduino based toll gate system using RFID. RFID is a radio frequency identification. So basically, what happens in our project is first of all, our gate gate is open, and when the vehicle pass, the first IR sensor placed there, the gate automatically closed, and there the driver have to pay the bill. And if the driver try to pass without paying the bill there, the gate will not be open. So the driver have to at first they have to pay the bill. Then only it is allowed to move forward. And when the driver pay the bill there, the person placed here allow him to move forward. And when the vehicle pass the second IR sensor placed there, the IR sensor automatically opens the gate, automatically opens the gate, and the vehicle is allowed to move forward, and it can move to its own destination. And the same mechanism is followed for other vehicles as well. So current challenge in toll collection system is basically there are more drawbacks in traditional toll collection system. So in order to mitigate that drawbacks, we have present this prototype. Slow transaction. Manual toll collection can lead to long queues and delays, frustrating drivers. Security concern. Cashless system are vulnerable to theft and fraud, posing risk for both operation and users. These are more the drawbacks that traditional toll gate system poses. Inefficient data tracking, lack of digital record makes it difficult to analyze traffic patterns and optimize operations. And introduction to Arduino technology. I think all are familiar with this Arduino. Arduino is open source microcontroller board. It is open source electronics platform based on easy to use hardware and software. It is designed to make the process of creating an iterative project more accessible. We can apply this in our electronic project. And the key features, these are more advantages that this prototype, which is low cost and flexible. Programmable using simple C or C+ code. Simple code is applicable in this project. Wide range of compatible sensors and actuators, support rapid prototyping and iterative development. And the main application areas where the Arduino is widely used in the IoT, is Internet of Things, automation, robotics, and iterative art project, among other applications. And these are the main things that Arduinos are used. Now, in order to describe the key components used in our project, I would like to depend on.
Wait, I want to mention one thing. Now we have on camera we have Nirdesh, and the audience to this presentation is computer CD batch. And there we have Honorable Jitendra Kumar Mananda sir also. So you can continue your presentation.
Thank you. Today I am going to explain about the component used in the Arduino based RFID toll gate system. First, Arduino. Arduino is the microcontroller board. It consists of this power supply pin, analog input pin, and these are the output pin. This is the USB port through which we will upload the code in it. But the code that we upload is directly not understood by this microcontroller chips. So this crystal oscillator helps to convert that code into the clock pulse So that clock pulse is used by this microcontroller to operate the different component connected to this Arduino Uno board. Second, servo motor. Servo motor is the electronic device which is used to control the rotation or control in a specific direction. It works on the pulse width modulation. Pulse width modulation means the process of extracting analog signal from the digital, which helps to control the rotation of the servo motor. Here in this project, this servo motor is used to open and close the door automatically. Third, IR sensor. IR sensor is electronic device which is used to detect the obstacle. Here this IR sensor detects the vehicle and transmits the signal to the Arduino board, due to which the door is open and closed automatically. There are two pieces of IR sensor is used in this project. Third, gridboard. Gridboard is a solderless prototyping tool which is used to connect the different electronic component without soldering. So this is very important. Here we use this gridboard to connect the different type of component like RFID, resistor, Arduino Uno, etc. RFID module. RFID module use radio waves to get information from the RFID pad. RFID pad is the internally circuited pad. When that pad is scanned by the RFID module, then the information is transmitted to the RFID module. If the information transmitted by that RFID tag match the information that the RFID module need, then it provides access and the payment is done automatically. If the RFID tag has not sufficient amount or sufficient balance, then it do not provide the access, as due to which the door is not open automatically. Keypad. Keypad is the input device which is mainly used in the ATM system, bank system and many other security system. Here keypad is used to used to recharge the RFID pad, which helps to pay the bill automatically instantly to get access, and which leads to open the door automatically. This LCD display. Here LCD display is used to display the information. If the RFID pad has not sufficient balance, then it display to recharge the RFID pad to get access. If the amount is paid automatically, then it display access granted, due to which the get open automatically and the user go ahead to reach their destination. Thank you for the further explanation. I would like to call my team member Deepak Nampal.
So, thank you, Divendra. So, let me explain the circuit diagram of this project. So, Divendra or Deeparsan also give the basic overview of this project. So, let me demonstrate or let me explain the detailed explanations and circuit connections of this project. So, we have used the two IR sensors. So, here is one and another one is two IR sensors. So, here is a servo motors. So here is the servo motors, and so here is a RFID scanner. So another one is keypad. So here is the LCD display with the I2C modulations. So let me explain the detail project. How does it work? Right? So we have so first of all, so there is a here is a IR sensors, and so connected with the two servo motors. Right? We have just to include the one servo motors here. So it works like the two servo motors. First of all, exiting door of the servo motor has been opened. So when the vehicles is entered, entering IR sensor detect the vehicles as obstacles, and so door has been closed. Exiting door has been closed. And when the vehicles is entered through the first IR sensors, in between the two IR sensors we have used this RFID module. So we have this RFID module to scan. We have used the tag. So tag means it is an internally circuited device, so which help to scan the RFID module. So when the tag has been scanned, the payment has been successfully done, and then one is allowed to go through the exiting door of this servo motors. That microcontroller send the message through the servo motor through the IR sensors, and IR sensors detect the serial communication through the microprocessor, and microprocessor allowed to enter the exit the vehicles. So if in the case of we have insufficient balance, if we have insufficient balance, first of all, first IR sensors detect the vehicles, but in the case of we have insufficient balance, so RFID module does not scan or so invalid this tag. So that means we need to recharge your card. So first of all, we need to recharge your card. So for recharging your card, we have to use this keypad. So keypad, so entering the numbers through the keypads. So entering the numbers through the keypads, we have to use recharge our so tag. So that means after recharging, so the process has been gone automatically at the microprocessors, right? So this is a basic overview of this circuit diagram. So here is the Arduino pin. So we have just sensors. So we have IR sensors are 3 pins. So one is VCC pins, another is ground, and so another was out pins. So out pin is connected to the A3. So analog pin 3, and so second IR sensors out pin is so connected to the A2 of the analog pin A2, and so remaining VCC of the pin is connected to the Arduino of the 5 volt. So ground is connected to the Arduino with the ground pin. So this is the connections of the IR sensors. So here is a LCD display with the I2C modulation. So if we have used only LCD in this project, so there is need a lots of wire connections, potentiometers and resistors as well. So this it overcome these limitations. We have used the I2C module. So that is significantly used 4 wire connections. So here is a SCL pin, another one is STA, so another one is ground, and another one is VCC pin. So SCL pin is red pin. So red pin connected to the analog pin 5 of the Arduino board. So another one is STA pin is connected to the analog pin 4. So rest of this ground pin is connected to the ground of this Arduino, and another is VCC pin is connected to the 5 volt of this Arduino. So there is something difference in the RFID modulations. So RFID scanner. So here is a VCC pin is connected to the 3.3 volt of this Arduino. Because we have used this pin 5 volt in this Arduino, so RFID so does not scan. It has been circuit out and is can't work. Right? If we have to use only 3.3 volt of this Arduino, use 3.3 volt of this VCC pin of this Arduino used in this RFID reader. So rest of this is, so there is a circuit of this keypad also we have explained briefly. So here is a 4, so here is a row column, and so here is a row wiring, and another one is column wiring. We have to use the resistors. So individual 1 k resistors to the column, and another one is 4.7 kilo ohm resistors through these rows. So here is a brief explanation of this circuit diagram. So let me explain the coding part of this project as well. So our friends. So here is a basic. I will explain the briefly. So here is coding so long. I think there is 300 lines around the code. So I will explain the briefly out.
Okay.
So we have to include the 6 so header file, that means library file. So we have to use the SPI.h. SPI.h means serial preferences interface. So it helps to communicate the MFRC, that means RFID reader to the microprocessor. So we have to include this header file to communicate the RFID reader. So another one is one wire keypad. So it is used for the keypad header file. So another is servo.h. So liquid crystal .I2C.h. It use the header file of the LCD display. So another one is Another one, so LCD display, so 0 by 27 means the address of the LCD. So this is address of the LCD. So 16 comma 2 the dimensions of the LCD. So that is 16 character in the row and 2 character in the column. So here is a servo. We have to include the servo variable. So servo. At the initial position, servo has 0 means rotations of the servo motors has been 0 angle. That means so scroll down. So we have to define the macro. We have to define macro definitions of the pins. So we have to RST pin of the so RFID to the pin number, digital pin number 8, and STP to the pin number 10. So card balance. So I will explain the BT. So it is a card balance for 2000. So card balance we have to use 2 tab for this project. So we have to use card balance tab. Number 1 has balance of 6000 and another one is 400. So we have to declare the string of number 1, number 2, card and card 1 and card 2. So number 1, number 2 is also you can use for the number 1, number 2 integer. So declare for the we have declared for the so balance. So let's scroll down. So stop. So we have to this the so character key, right? So that means we have to character 4 by 4 characters in the keypad. So we have to include the individual characters. So 1, 2, 3, 1, 2, 3 and A, 4, 5, 6 and B and 7, 8, 9 and C and so we have rest of these character has been included as we have in the given to the keypad. We just have to explain by Dipendra. So one wire keypad, so it is a print for the output 16 for the characters. So KP2 KP2 serial for the output. Keys 4x4 is the keypad dimensions. So analog pin. So A0 is the pin of the connections of the analog. So 470 is the resistors. So 1000 is the resistors. We have to connect to the column. So let's scroll down. So first of all, we have to initialize the LCD. So for the backlight, we have to initialize the LCD dot backlight. So serial dot baud. So 9600 means the baud rate. We have to seen into the serial monitor and servo motor. Initially, we have to attach. So on the top, servo dot attach dot 9 means we have to connect the servo motor to the digital pin number 9 and scroll down. So pin module, so buses, we not need to buses, sir, I have to include that also. So SPI means serial preferences interfaces. So with help to communicate the RFID module. So scroll down. So first of all, LCD dot set cursor 0,0 means so there is a one step off. That means one rows and one column in the 0,0 cursor means so the LCD of the dimension 1 rows and 1 column have been displayed by the automatic pole, and that 1,0 means so rows is 1 and column is 2. So display the connection system in the display. So let's scroll down. So for the if recharge is 00, so recharge. So scroll down. So LCD cursor 0. We have to enter the vehicles. We so shows the welcome. It is easy to understand. So let's scroll down. So it is easy to understand. So everybody has. So stop. So we have a servo down. If vehicles has been injured, so servo has been down, and we have to use for loop for these rotations of the servo. So initially servo has 90 degree, and the servo positions have been less than 180 has been rotated down, and it continuously rotates. I have to use this loop as well. So while servo off, and the same case in the down we have in the off as well. So scroll down. So same variable 1 the sensors. So IR sensors variable 1. So connected to the digital read. So digital read means so we have to read the sensing value from the IR sensors to so microprocessors, right? So we have to use this string constant for byte equal to 0, right? So for the RFID, so let's scroll down. It is easy to this one as well. So I have explained each and each line, so it takes too much time. So I have skipped this part. So for the keypads, we have to press the button in the keypad. So it shows the keypad is going to press. Then so key has been successfully pressed, and the serial communications of the keypads to the microprocessor has been successfully. So that makes the keypad press when you have to press the keypad. So this serial of the communications has been sent to the microprocessor, and the microprocessor has also give the information to the IR sensor and servo as well. So LCD cleared, so we have to clear by LCD. So dimension 0. Okay, so let's scroll down. So it is too much length. Okay, so here is a number 2. So here is a number 2. So number 2 means balance. So we have to introduce. So to derive further. So number 2 is balance 2. That means we have to introduce as a card tag 2. Tag 2 for the introduction. Number 2 is data. So if the card balance 2 is going to give the number. So number plus total balance plus card to balance. If we have to scan successfully and we have the card has been scanned successfully, so that makes so allow the card so exiting through the IR sensors. Okay. Scroll down. So here is the overall code in this project. So if I explain this each and individual line of this code, it takes too much time. So I have stopped here. So here is a code. So if anybody needs to this code and project diagrams, so you can contact me as well. So it's me Deepak. So I will.
Just wait. Come here. So come here. So let's appreciate him for his confidence.
I will request you come the rest of this explain the rest of this presentation to our friends. So Dipendra Khadka.
Now let's explain the benefits of Arduino tollgate system. At first, it increases the efficiency of the tollgate system. The automatic RFID based payment and variable to reduce waiting times and traffic flow. And at secondly, it enhances security, where the cash transaction can be done, and also the records can be kept at a safe place in the server, which can be retrieved if needed. It also helps to improve the data tracking. The system generates detailed reports on the traffic patterns and transactions, enabling data-driven decision making. And at last, it is also cost-effective as compared to the proprietary tollgate system. And for the future enhancement, what we can do is we can develop a mobile app where the user can manage the toll accounts, top up their accounts, and receive the real-time traffic update through the mobile app. Also, we can use renewable energy like solar system to power up the entire tolling system. And as in place of RFID, we can use ALPR or ALNR, automatic license plate recognition or automatic number plate recognition, which won't require any kind of additional tax in the vehicles. Only these license plates are required, which are scanned by the cameras, and the information can be retrieved through the vehicle. And at our conclusion, it offers a various transformative solution for modernizing toll collection system. By leveraging its capabilities, we can create a smarter, more efficient, and user-friendly toll gate system that benefits both operators and drivers. And I would like to conclude our presentation here. Thank you.
Okay, audience, let's congratulate him for the presentation on the confidence, on the good slides, and let's have some suggestion, Bikal sir, to their project.
Okay, first of all, thank you very much for your presentation. Your efforts that you have put into this project is really praiseworthy. अब तपाईहरुको प्रेजेन्टेसन हेर्दाखेरि चाहिँ अब मैले एउटा के फिल गरेँ नि मेहनत चाहिँ तपाईहरुले गर्नुभएको छ त्यसमा त नो डाउट हैन तर हजुरहरुले अझ डिस्कसनमा चाहिँ इडिसी वाला फ्लेभर ल्याउन सक्नुहुन्थ्यो कि जस्ट समवेयर तपाईहरुले जस्तै अर्डिनोको बारेमा बढी डिस्क्राइब गर्नुभयो हैन अनि कम्पोनेन्टको बारेमा डिस्क्राइब गर्नुभयो अब त्यसको धेरै डिटेलमा जान जरुरी छैन जस्तै तपाईले किप्याडले कसरी काम गर्छ भनेर त्यसको एक्चुअल सर्किट कनेक्सन देखाउन सक्नुहुन्थ्यो होइन। जस्तै रो र कोलुम आइडेन्टिफाई गरेर कसरी की प्रेस डिटेक्ट गरिन्छ त्यसमा चाहिँ तपाईँले भन्न सक्नुहुन्थ्यो। अनि तपाईँले चाहिँ जस्तै सर्भो मोटरमा त्यहाँ कुनै ड्राइभ युज नगरेको देखेँ कि मैले। ड्राइभ केही राख्नु पर्दैन, जस्तै अप्टो कप्लर अथवा रिले।
छैन,
कति भोल्टको सर्भो मोटर हो त्यो?
5 भोल्ट
5 भोल्ट। तर नर्मल्ली एउटा सजेसन के हो भने र यस्तो मोटरहरू जस्तो सर्किटहरूमा चाहिँ हामी अलिकति आइसोलेसन गर्न सक्यौँ भने अलि सर्किट प्रोटेक्टेड हुन्छ होइन। कहिलेकाहीँ तपाईँको त्यो अर्डिनोले चाहिँ त्यो रिक्वायर्ड करेन्ट दिन सक्दैन कि ड्राइभ गर्न सक्दैन। त्यस्तो अवस्थामा चाहिँ हामी आइदर अप्टो कप्लर अरू तपाईँको चाहिँ रिले राखेर चाहिँ त्यसलाई चाहिँ सेपरेट गर्न सक्छौँ भने अर्कै पावर सप्लाईबाट ड्राइभ गर्न सक्छौँ होइन। सो त्यो एउटा सजेसन भइहाल्यो है। अनि अबदेखिको डिस्कसनमा चाहिँ अब तपाईँले जुन कन्टेक्स्टमा यो प्रेजेन्टेसन बनाउनु भएको नि त्यो सब्जेक्टको थिम आउनु पऱ्यो कि। पुरा डिस्कसनबाट तपाईँले चाहिँ अब इडिसीमा गर्नुभएको हो नि त यो प्रेजेन्टेसन होइन। सो इडिसीको बेसिक कुरासँग म्यापिङ गरेर त्यसलाई हाइलाइट गर्ने कि। कुरा बुझ्नुभयो कि भएन? अब यहाँबाट एउटा लर्निङ भयो होइन। अनि अबको फर्दर प्रेजेन्टेसनहरू अरू सब्जेक्टहरूमा पनि तपाईँले त्यो कुरा ख्याल राख्नु होला है। जहिले पनि फन्डामेन्टल कुरामा म्यापिङ गरेर त्यसलाई बढी फोकस गर्ने। अनि कोडिङ एक्सप्लेन गर्न तपाईँलाई डिफिकल्टी भइरहेको थियो होइन। भन्नाले तपाईँलाई त सबै आउँछ तर टाइम एकदम लिमिटेड छ, अब सबै बुझाउन गाह्रो छ। त्यही भएर मेरो सजेसन के छ भने कोडिङ पनि बुझाउनलाई कहिलेकाहीँ हामी डायग्राम राख्न सक्छौँ कि कोडको फ्लो डायग्राम के। यसरी यो फङ्सन कल गर्यो, यसलाई यसपछि यसलाई कल गर्यो, यो कुराहरू युज हुन्छ र समराइज गर्ने। पुरै बुझाउँछु भनेर लाग्नु हुँदैन कहिले नि प्रेजेन्टेसनमा। कुरा बुझ्नुभयो नि? त्यही भएर कहिलेकाहीँ कुनै चिज डेलिभरेटली तपाईँले त्यसलाई चाहिँ कन्साइज बनाएर सठिक रूपमा भन्नुपर्ने हुन्छ है। त्यो कुरा ख्याल राख्नु होला। सो बेस्ट विसेस है त।
थ्याङ्क यू भेरी मच विकल सर फर यर भ्यालुएबल सजेसन। इभन अडियन्सलाई पनि राम्रो सरले सजेसन दिइरहनु भएको छ तिमीहरूको पछिको कामको लागि। र मेरो तर्फबाट अब चाहिँ नि थोरै होइन एक्सिलेन्ट हुँदाहुँदै पनि थोरै क्रिटिक के गर्नुपर्ने भयो त भन्दाखेरि अब प्रेजेन्टेसनमा टाइम डिभिजन चाहिँ नि भाइकोमा अलिक बढी टाइम भयो होइन, अरूकोमा अलिकति टाइम कम भयो। अनि त्यसपछि फर्दर हामीले यस्तो प्रोजेक्टहरू गर्दाखेरि चाहिँ नि के हो कोड मिनिमाइजेसन, कोड अप्टिमाइजेसन गर्न सकिन्छ कि भन्ने कुरामा चाहिँ प्रयासरत रहनु। बाँकी धेरै राम्रो। थ्याङ्क यू भेरी मच।